Right, I'm going to show you how to use something called choice chambers to investigate a simple animal response called taxis in invertebrates. The best invertebrates to use for this are maggots from the local fishing tackle shop, or even you can go out and collect woodlice. Okay, now this is a choice chamber, and it's basically like a giant perspex petri dish. In the base, it's divided into 4 sections, and the idea is that you create different conditions in these sections, okay? And then you can place your maggots in there or whatever you're using, return the lid, and you can observe where they prefer to move. Now, can I remind you that what we're investigating here, taxis, is a simple animal response where the direction of the response is related to the direction of the stimulus. So they're moving towards or away from different stimuli. Now, here's a choice chamber that I've prepared earlier. Okay, and what I've done, you can see I've set it up in this way. I've got half of it that's going to be in the dark, and I've done the same with the lid by putting a piece of black paper in there. The lid will go on there. Okay, I've created 2 damp sections by placing damp paper towel in the bottom there, and 2 dry sections. In the dry sections, you can actually place some silica gel if you like to ensure that conditions are dry. And you could even put something like cobalt chloride paper in there, which remains blue if conditions are dry, just to check the conditions. But I find this is not really necessary. Okay, so once we've set that up, the next thing we do, we place a thin nylon sheet over there, and then we place the lid onto the choice chamber. Okay, you can see I've got a little escaped maggot from the last time I did it there. Okay, that shouldn't really be there, but we can ignore it. Now then, the next thing we're going to do, we're going to place 20 maggots or woodlice into the central little hole there, into the choice chamber. Okay, just to make sure that the dark sections are in darkness here, I'm going to cover half of it with a dark cloth like that to keep the light out. Okay, and then I'm going to leave it for 5 minutes before I remove the lid and count the number of maggots in each section. Now, this is something that you should repeat several times, okay? So 3 times this experiment should be repeated in order to get any kind of reliable results. Okay, now I'm going to move that out of the way because I've actually done this investigation earlier, and these are my results. Okay, so here are the 4 different sections, the 4 conditions we had in the choice chamber. These are my raw results, the number of woodlice in each section after 5 minutes. And I did use 20 fresh woodlice each time, well, fresh maggots in my case, okay? What I've done first of all is worked out the mean there, okay? And these will act, the means will act as the observed results when we do a little calculating later. Now, looking at this, it does appear that the maggots seem to prefer damp conditions, and they do seem to prefer dark damp conditions to any others. But we cannot draw a valid conclusion from these observations. As scientists, we have to carry out some kind of statistical analysis. Now, the statistical test used in this case would be the chi-squared test. This symbol here represents chi-squared. This is a test that actually compares observed results of an experiment to the results you would expect if the thing you're investigating has no impact, in other words, if the null hypothesis were true. This is how we calculate chi-squared. So chi-squared is the sum of the observed results minus the expected results squared divided by the expected results. And this is a nice little table you can use to actually calculate your chi-squared. So you see here in the first column, I've got my observed results, so that's the means that I've just calculated from my raw data. So the mean number of woodlice in each area. The expected results in this case are all 5 because I used 20 maggots, and if the maggots had no preference over where they moved, we should expect to get them pretty evenly spread, so 5 in each section. Okay, now to do the calculating. It's a very easy test, so the first thing we do in our first column here, the first thing we do is calculate the observed minus the expected results. So there, your observed result minus 5. We do tend to get some negative values here sometimes. Okay? The next thing we do, once we've worked out observed minus expected, we square that result. That's simply to get rid of the negatives, but we do have to square every single one of them, negative or not. Okay? And the final step, once we've done that squaring, we do the result we've just calculated there, divided by the original expected result, which in this case was 5. Now, to calculate our chi-squared, all we have to do is sum those results. In other words, add all 4 of the values we have there together, and if we do that, we get 2.51. So the result of the chi-squared test in this case is 2.51. Now, on its own, that value has no meaning. So what we have to do next is look up our chi-squared result on a probability table. In order to do this, we have to calculate the number of degrees of freedom in this investigation, which is always the number of categories minus 1. We had 4 different categories, 4 conditions that we were investigating. So 4 minus 1, we have 3 degrees of freedom in this investigation. So we now look at our probability table for 3 degrees of freedom, and this is the critical value. Now, we are going to compare our chi-squared result to that critical value to see if it's higher or lower. Now, if our critical value of 2.51 is lower than the value in the table here, it tells you what to do with it, okay? So 2.51 is less than the critical value, therefore the differences between the observed and expected results are not significant. In other words, there's not a real difference, so the null hypothesis has to be accepted. Basically, the maggots had no preference where they moved in this particular investigation. So what we would write in our conclusion is that the probability of the results occurring by chance is greater than 0.05, or in other words 5%, so there is no real difference between the observed and expected results. Obviously, if you do get a chi-squared value that is higher, then it would be the reverse conclusion and the results would be significant. There would be a significant difference between observed and expected results.